Hey guys, so I'm going to make a video on trigonometric integrals in your textbook, page 536 to 541. So you can follow along if you're using this textbook. So what we're going to look at in this lesson is how to solve trig integrals involving powers of sine and cosine, or secant and tangent, and then solve trig integrals involving sine and cosine products with different angles. All right, so integrals involving powers of sine and cosine are going to look something like this. So you have sine to a power times cosine to a power, and or secant to a power times tangent to a power. And we're going to look at how to work those integrals, how to figure them out. Okay, so for instance, you can evaluate sine to the fifth x times cosine of x with the power rule by letting u equal, so you could use u substitution and let u equal sine to the fifth. And then du is 5. Oh, hold on a second. You can just I did that wrong. Let u equal sine of x. And then du is cosine of x dx, and then it becomes u to the fifth du, and you can integrate straightforward using u substitution. A lot of these problems are not going to be quite as straightforward as that, of course, because that's how calculus is, but that's okay. We love it anyway. All right, so you're going to want to know these identities, the Pythagorean identity, sine squared x plus cosine squared x equals 1. I think we've gone over that quite a bit. Hopefully you've got that one nailed in it's like up here in your brain. But these half angle identities for sine squared x and cosine squared x might not be as clear, so you should write those down. They are in your textbook as well. On the very first page, 536. So if you see sine squared x, it can be rewritten as 1 minus cosine of 2x over 2, and we're going to use that quite a bit in this lesson. And cosine squared x can be written as 1 plus cosine of 2x over 2. All right, so on page 536, there are some guidelines. If you see integrals with powers of sine and cosine, and you know that, okay, I've got to do something that I learned in 8.3. These are your guidelines you want to follow. It's on page 536. So if, for the first one there, if the sine is to an odd power, then what you're going to want to do is convert the sine to cosines, and I'll show you some examples of how to do that, but you're going to probably, when you're doing your problems, want to go back to these guidelines to determine how to get started on these problems. All right, the second one says if sine or the cosine is to an odd power, then convert that into sines. And then if the powers of both sine and cosine are even for this third one, and non-negative, make repeated use of these identities that we just went over, those half angle identities. Okay, so look at example 1 here. We have sine cubed x times cosine to the fourth x. Go to those guidelines and think about which one it fits. And we have a sine that is to an odd power, so that's going to fit in with this first guideline. So we are going to convert to cosines. All right, so these problems are all in your book. However, you should write them down and go through them with me step by step, pausing as we go if you need a little bit more time to write things down or to digest the material, or to go, how did that happen, and maybe rewind and go through it again. So in order, so the degree of the sine is odd, so we're going to convert to cosines, and we can rewrite sine to the third power as sine squared x times sine of x cosine of x, cosine of the fourth x. So all I did was, if I take sine squared x times another sine of x, that's sine cubed, so I haven't changed anything yet. But then what we can do with sine squared x, because we have this Pythagorean identity, and it says in the guidelines to convert sine to cosine, we can, if you subtract cosine squared x from both sides of this identity, we get sine squared x equals 1 minus cosine squared x. And an identity can be rearranged like this all day long, just it's still an identity. And so now I can replace sine squared x with 1 minus cosine squared x. And then what I'm going to do is I'm going to switch these to the place of those two factors. So I have cosine to the fourth x and then sine of x dx. Okay, so then so where to go from here? And again, like knowing what to do with these, you got to pay attention to the guidelines, and you have to do a few of these before you start to get it down. Kind of like how we had to do a few practice problems with integration by parts, but it seemed like then you start to get it, and then it's like, oh yeah, okay, I can do this. So we're going to distribute the cosine to the fourth power. So I have cosine to the fourth x when I multiply it by 1, and then minus cosine to, you add your exponents, so it's cosine to the sixth x, and then I still have this sine x dx over here. Okay, now think about what you could do here. At this point, we can, if you let u equal cosine of x, then our du becomes, okay, so then we have our u substitution. Let's put that into our integral. We end up with u to the fourth, oh, I never finished this, sine of x dx is my derivative of u. So it'd be u to the fourth minus u to the sixth du. And then you can split it up into two integrals, or you can just straight up integrate. It's going to be u to the fifth over 5 minus u to the sixth, nope, u to the seventh over 7 plus c. And then put your u back in here. What did I do wrong? You guys need to, hopefully you caught this. This should be a negative sine of x. Okay, so it's been a long day. It's towards the end of the day, so I am obviously making some mistakes. I need to put in, let's back up here. I needed a negative sine of x because the derivative of sine of x, or the derivative of cosine of x is negative sine of x. So I had a negative there, which means I need a negative out front here as well. And so I have a negative times these terms here. I'm just going to change their signs. So I end up with negative u to the fifth. Instead of u, I'm going to write the cosine back in here. Cosine to the fifth x over 5 plus, so I have a negative, this negative times this negative, so it's plus cosine to the seventh over 7 plus c. All right, that is example 1. So I'm going to go through and do one example per video. So I will see you in the next one.